What if your company's employee could ask a question like this? Can I get a refund? Can I get a refund? Within seconds, the assistant retrieves the relevant enterprise policy, performs semantic search across organizational documents, and generates a grounded response based on the company's approved refund policy. In this video, I will show you how this enterprise AI platform works, the business problem it solves, and the architecture behind it. Hello everyone, my name is Tijani-Abagaro. Welcome to episode 1 of my Enterprise AI on AWS series. Today, I wanted to introduce an enterprise AI assistant platform designed to address one of the most critical challenges facing modern data-driven organizations, such as how to securely and reliably transform vast repository of enterprise knowledge into an intelligent conversational asset. This solution utilizes Retrieval-Augmented Generation or RAG framework. By doing so, the system ensures that every response generated by the platform is strictly grounded in verified, authoritative enterprise documentation, rather than relying on large language model pre-trained data. Over the next few minutes, this presentation will walk through the core business objective, examining the logical architecture, and demonstrate the platform executing production-style workflows. Whether you are CIO evaluating enterprise AI, a cloud architect designing modern knowledge platform, or an engineer building a retrieval-augmented generation system, this demonstration illustrates a production-style implementation on AWS. All right, let us talk about the enterprise knowledge challenge. On this presentation, I will explain the enterprise knowledge challenge. To understand the architecture, it is essential to examine the business problem it solves. Large enterprises maintain thousands of critical documents scattered across business units, ranging from intricate refund policy in the HR manuals to operational procedure and the strict compliance frameworks. The friction today isn't a lack of information, it is the time to spend retrieving it. Employees routinely lose hours navigating fragmented data silos. Furthermore, out-of-the-box public AI assistants introduce immense compliance and operational risks because they are prone to hallucination or operating without business-specific context. The business objective of this platform is to bridge that gap, enabling workforces optimizing through natural language queries while ensuring absolute compliance by anchoring every output to approved organizational data. All right, what is measurable business impact? Workforce efficiency. It increases like the productivity of our company. How it increases productivity of our company? Like the employees no more searching fragmented data across multiple systems. They are not searching across 100 terabytes of data or petabytes of data in order to provide us the response for our query. Instead, they use this system, enterprise AI assistants, in order to get the answer within seconds. The other thing is it mitigate risk mitigation. Whenever companies actually use like a public model, public large language model, they prone to actually hallucination. There is also actually compliance risk. So whenever we use these kinds of things, this enterprise actually gets the company's policy from trusted source and integrates that company's refund policy into the query in order to provide the accurate, up-to-date result that comply with the company's policy and with the regulatory requirements. The other benefit of uh, this enterprise AI assistance is operational scalability. Operational scalability in a sense, like whenever we do these things, we are not going to communicate with the desktop uh, support. We are not asking anybody, or we are not getting a ticket in order to actually get the important information about the refund. Rather, we are going to use this, the system itself. We are going to chat with that in order to actually get self-services. The other thing is actually the future proof of asset. What does that mean? It means this is reusable system. So once the other application developed, it will totally integrated with this one without actually recreating certain things. All right, let us look into Enterprise Refund AI Assistant logical RAG workflow. Let us look at the logical data flow that enables this capability. The architecture separates ingestion from inference to maintain high throughput and low latency. When a user submits an inquiry, the platform does not pass this directly to the language model. First, a query is converted into vector embeddings. So once it converted it to vector embeddings, that means a mathematical representation of its semantic meaning. Next, the platform executes high-performance vector search against the document index to retrieve the exact, highly relevant segmentation of the enterprise data. That means from vector database. This retrieved knowledge is then programmatically combined with the user's original question into augmented prompt context. Only then this context delivered to the foundation model to analyze a response. Yeah, finally we are here. We are at Enterprise Refund AI Assistant platform, and let us actually chat with it. AI assistant. So let us look at the implementation executing in a live scenario. So using a sample set of complex corporate travel and refund policies. Suppose an internal agent query the platform. What is the refund policy for a ticket canceled within 24 hours? Let us ask, what is the refund policy for the ticket cancelled within 24 hours? 24 hours. Let us ask. The platform returns a definitive answer instantly. Behind the scene, the workflow captured the query, calculated its vector coordinates, matched it against the refund policy matrix inside OpenSearch serverless, and used Bedrock to analyze this compliant answer. Let us observe how the system handles the boundary condition. For example, let us ask what happens if I cancel after 48 hours. What hap hap what happen? What happens if I cancel after 24 hours? After 48 hours, let us say. What it is saying, so as demonstrated, the platform accurately differentiates the policy change based on the time boundary, citing the specific fee structure embedded in the underlying enterprise documentation. As you can see, it is rule one of like this one. It's actually detailed according to that. So finally, let us look at the cross policy query. Can I transfer my ticket to another person? Like that. To another person. Let us ask this one. Can I transfer it? The architecture clearly isolates the relevant causes, avoiding agentic AI hallucinations and delivering an exact auditable business response based on strictly on the documentations. So that's it. This functional implementation represents the foundational milestone of a broader enterprise blueprint. The upcoming episode of this series will peel back the layer of this platform. The technical deep dives will review the end-to-end AWS resource configuration, the declarative infrastructure as code, deploying using Terraform, automated CI/CD pipeline, execution via GitHub Actions, and the specific data engineering required to optimize OpenSearch vector indices for enterprise search. Thank you for watching, and the deep technical engineering begin in episode 2. By the way, there is GitHub Action publication. So I attached here, so click here. Thank you.